what we have is that the entirety of our feeder volume is being divided into two things, right? The amount that is wasted here is by being shrunk. That volume we can never get back, okay? That's just life. That's the way it is. But the rest will be whatever is left over here times the shrinkage, so minus alpha VC. It's not entirely important that this process is something you memorize, okay? All you need to know is that VF is equal to alpha VF plus alpha VC. The volume of the feeder is equal to alpha, because it's the same here and here, times VC plus VF. But also we must know that feeders have a certain efficiency associated with them, and it's called E. So EVF is equal to alpha VF plus alpha VC. This is the only equation you basically need to know in terms of volume, okay? And this, you know, is always 3.16. These volumes are going to be part of your other calculations where you're working with volumes, like for example with the modulus, where we have the volume over area type thing. We're going to have a lot of equations, and you're going to solve the unknowns, and they will give you the efficiency, or you'll calculate the efficiency, but you'll be given something. It's not something you just have to pull out of the air. And yeah, that literally, this is the extent of the equations they can ask you. I'm just going to go down to see that equation or that question about efficiency and volumes and things. Yeah, I don't go into a lot of other detail, but we do have some more notes about volume and area. So I just want to say these things. I just reiterated here that the percentage change in volume is alpha, which is 3.16 generally. The volume, VF, is equal to VC alpha plus VF alpha, but we already said that. It's just typed out. The volumetric shrinking of the casting plus the volumetric shrinkage of the metal, okay? The actual usable volume is this times efficiency. So this is things we've already said. Okay. We need to actually think about what the volume is. And you have this big shape full of little things. You literally just have to do calculations of the individual shapes and, add them together for the volumes and the areas. So might be worth just making sure what the formula is for like a cylinder or a rectangle, but I mean, it's not that hard. But if you're anything like me in exam, I once spent 20 minutes trying to remember what the formula, I think, for the area of a triangle was. This was like in second year, because you don't think about it much, man. You think about Reynolds number and entropy. You never think about triangles. It happens to the best of us, man. Just always remember to study the dumb things beforehand. So this is in general little tips. The total volume is something you have to calculate. It's easy to split it into simpler shapes, and you subtract the volume of any cores used, because obviously that's not going to be used up by the metal at all. Ignore the volume of small holes because they're going to be drilled in afterwards. So obviously the things you're going to be casting, the amount of metal you need, is still going to fill the place where that hole is going to be. You're going to drill in the hole afterwards. For the surface area for those modulus calculations, where the m is equal to v over a or whatever, the area that we're thinking of here is the casting, the surface area where heat is lost to the mold, okay? So only the surfaces that are actually in contact with the mold, in contact with the sand. If they are joined, the interface area is not a cooling surface. So just think of all the areas that are actually in contact with the mold. So these areas would be in contact with the mold, right? And this one at this side and the other side. Okay. This is the thing I just want to note. Like, I made a note for myself that it usually doesn't count a huge amount of marks. it takes so long because sometimes it's like a really complicated shape. So just prioritize maybe writing all your calculations and maybe the entire method and everything you need to do, and then leaving this for last, because it's going to take a lot of time, and for like 5 marks it's not worth it, where you could actually get it like a good amount of work in for a different question. I did make a note of this, but I don't think it was ever asked in a different any part of or any past exams. But yeah, I did make a note of this. This fun little part of the guide is literally things you already know. So this is supposed to be alpha, not A. But this the efficiency of the feeder. Efficiency times the volume of the feeder is equal to alpha BC plus VF. Okay, this is the general modulus. Modulus is V over A. The feeder modulus or time or whatever is equal to 1.2 times that of the casting. This is just in general for a cylinder though, because it's pi over 4 d squared L, which is the surface area of a cylinder, over pi dl. So this is in particular for a cylinder. You also have a section for phase diagrams and temperature determination. I'm not going to go into this for details in details because this is material science work. I'd recommend watching a video on it. So just literally just go on YouTube and do a little bit of revision on how to do these. All I can say is when you do need to draw these diagrams, the top tiny little corner of the diagram in the paper is the shape that you want to aim for, which is this shape. So that's the shape you're going to try to copy when you're going over it. So yeah, I just made these little notes, and phase fractions and just the general naming convention is here because these are just things that I tended to not remember or need reminders of in the exam. But yeah, that is basically all the calculations needed. Just want to show you some of the calculations here. Here you can see literally what we just did. This is efficiency times the feeder volume is equal to alpha, which is 3.16%. So that means it's 3.16 divided by 100. Remember, I've been saying 3.16. It's 3.16 divided by 100 because it is 3.16%. Really important. 3.16 divided by 100. NB, NB, NB. If there's one thing you need to remember, divide by 100. Okay? Otherwise it's going to be weird values. So yeah, there's literally the calculation we did. As you can see here, in all of these calculation questions, it is literally just writing our equations, everything we know. Here's the modulus. Here's the 1.2 thing. Here's the volume over area. And then finding the diameter. It's always the same formula. Like, not formula, but I mean like the same method. If you practice like 1 or 2 of these, you've got the method down. You'll ace the sand casting part.